So, Jonathan, what do we have in the inbox today?
We got a lot of spam, I'll tell you that. But as we go through some of this, let me see. Oh, we got a good one here pertaining to L1 columns.
Ooh.
So as you know, L1 columns are designated in the United States Pharmacopoeia as a C18 bonded phase. And this myth is asking if they're all the same.
Oh, that's right. So the USP will designate, if there's going to be an HPLC analysis, they designate whether you have to use an L1 column or not. But that's really not a lot of guidance, because there are a lot of L1 columns when you look out there that you could choose from. And, you know, the question is, do they all perform the same?
Exactly right. I think there's over 600 L1 columns you can purchase from. 600!
Yeah.
All right, Kim, so now that we have a good understanding of what the myth is, how do you want to go about testing this?
Well, I think we need to test a range of columns, but all under the same conditions with the same set of compounds to make sure that we're getting a real good comparison of their performance.
I agree.
Let me get some columns.
Great. Oh, are we going to run all those?
I think we can.
All right.
All right, Jonathan, we tested all of these columns here.
Yeah, we ran them all on our Acuity H-class system, all isocratically under the same conditions, just to confirm whether or not those columns performed equivalently. So let's see how the results look.
Yep, this should give us enough data to decide whether or not all L1 columns are created equal or not.
Agreed.
Okay, now from all those columns, we generated an awful lot of data. Now remember, we compared all of those columns under the same exact conditions, same mobile phase with the same sets of compounds. They're all L1 columns, so by that USP designation, they're equivalent. So let's see if we actually got equivalent results.
Yeah, Kim, and I got the results right here. So as you take a look at these here, you look at from all these 6 different vendors, vendor A through F, you'll see a significant difference in overall retentivity and selectivity for the columns that we looked at. Peak number 6, for instance, if you want to track, that's the neutral analyte naphthalene. That has a completely different retention time for the different columns that we chose that are all L1. So you can see this data here supports it. They don't all perform the same.
So what are those different characteristics that make these columns perform differently?
Kim, there's so many things. When you think about particles and columns and column technology, base particle plays a huge role in that overall retentivity and selectivity, not just the bonded phase like the C18. You have such things as pore volume and surface area. Those all help dictate the overall retentivity of the phase. The actual surface coverage, how much C18 you're actually putting down, that can impact the retention as well. And then you got to think of other things too, like metals maybe potentially in the older phases. Embedded polar groups that we talked about in another episode, they all impact the selectivity. The surface charge, whether it has a slight positive charge, all really can play a huge role in how that L1 column performs. So understanding those are very important.
All right, Jonathan, so we've seen the data. How do you want to call this one?
It's totally busted. Totally busted. Not all L1 columns perform the same. There's a lot of differences in there. So if you're running a USP method and it requires an L1 column, it might be advantageous to try a few different ones.
Right. There are so many key attributes that affect the retentivity of the column and the compounds that are running through it.
Yep.
They're just not the same.
Not the same. Busted.
Busted. If you'd like your question to be answered on a future episode, please feel free to email us at trustyourscience@waters.com.